I want to talk a little bit about my daily business as a designer and studio acoustician, or acoustically used rooms. And just see that I'm missing an A. And I want to say that studio design or design of acoustically used rooms is not just only about acoustics. It's more or less bringing everything into balance. Ulrike already mentioned a few things like power, for example, which is so important. And only if everything works together and is fine, you can do a proper job in there as an audio engineer. So maybe we just saw these big mixing consoles, just to give you an idea. Such a mixing console has in the room already 5 to 8K kilowatts of heat. That means one sitting person has 100 watts. You can imagine what alone the desk is doing in that room. And you have to get rid of this heat. And at the same time, be very quiet, not to disturb. And this all comes together, and you only can do a job if everything's working. So this, for example, is Redbox Studio here, this picture. This is from Florian Opale. He's the ex-Jethro Tull guitarist. He's living close to here. So these milestones in a studio project is like in an architectural office. So the first step is basic evaluation. Then you have a drafting phase. Then you have this preliminary drawing and building permission phase. Then you start with the detailing, draw all these small details and execution planning for the companies who are building the whole thing, tendering and offering phase, execution and site supervision, which is very important, and then final evaluation and measurements. We only have time for the first, let's say, 3 steps, and I try to put you on the journey with me together, do the first steps in such a studio project with some examples, of course. So I want to get a little more into detail with the first step, this basic evaluation phase, and I divided it in 3 smaller phases. The first one is, I call it the interview phase. So this is learning about expectations and requirements from the client, the owner. What is the purpose of the studio or studio complex? Is it a dubbing stage? Is it made for recording orchestras? Is it mixing theater, and so on? And there are some differences which are very important for later on. Then, is it an existing building or is it a new building? What's the available space? The structural data, so from the structural engineer, ceiling heights, and surrounding situation. What happens around that studio? Are there train tracks? Is there underground, or is there an airport close by or something like that? And probably, is there already kind of a budget? So what you see on that picture, so this is a 3D visualization, sorry. This is from Florian Schneider from Kraftwerk. Unfortunately, he passed away some months ago. He was a very, very nice guy. And his idea in that control room was to include 2 of these huge horn speakers for very old movie theaters. Very interesting idea, and it was a lot of fun to work with it and see the results. The next phase is the translation. So this is all about translating all this info out of the interview into physical data. So kind of put numbers in dBs and so on onto it. Out of that, what kind of space do we really need? What ceiling heights do we really need? So, for example, the thing with the space, very often people are looking for, let's say, I want to build a control room and a recording room, and they say, okay, we need 30 square meters for this and 30 square meters for that. So we are looking out for a space with 60 square meters, but it's not like that. You need a corridor, maybe you need a technical room, maybe you need space for air conditioning system. It's also about the ceiling height then with all the ducting and so on and so on. So already you try to get a feeling about that, what is really needed. You need corridors, you need space for the isolation, for the isolating walls, for the room acoustic treatment, and so on and so on. And with experience, you kind of can do the math and do a proper calculation what you really need. As well as depending on the needed isolation, you have to already think about what kind of load do we have on the floors, for example. And last but not least, think about the ergonomics and the room interactions. For example, there's a recording room and there are 2 or 3 control rooms who want to have contact to that recording room via window or something like that. And how will the path look like between the rooms? Does this work properly? The next step would be a feasibility check. So the evaluation of the building, is it fit for purpose, or the building area if there is not an existing building already. So you have to check what are the problems. We have to look into the structural plans. We have to check the ceiling heights. We have to check if there is enough available space to put everything into it, what the client asks for. And of course, like in this project, this is FFS studio in Munich. This is a dubbing stage, and you have to be very, very quiet in these recording rooms because sometimes the actor is whispering and you don't want to hear something from outside, of course. The problem here, they wanted to stay in that building here, and next to it is the main connection between the Eastern train station and the main train station here in Munich, with 6 main tracks, not only for personal transportation, but also for goods. You can imagine what's going on here. And this is the distance from the building here to there. It was just about 5-6 meters. So you get all these vibrations of the tracks into the building, and the resonance frequencies of the ceiling slabs are most of the time around 30 to 40 hertz. And you can imagine what happens if something goes wrong here. For example, what could go wrong? You start putting isolation measures in there. Room within a room construction, like in a standard situation, and all these resonance frequencies of these measures are most of the time around 25 to 50 hertz. So in other words, when the whole building is shaking with about 35 hertz, like in this example here, the whole system goes into resonance, and inside of these rooms, it's vibrating even more. And then you start hearing overtones and all that stuff. So it's not only about the problem with 35 or 40 or 50 hertz, it could be even worse. Electromagnetic field, something which is close to this thing with the main power. Just a story, just recently we had a project for Max Martin, which you probably know, with all about 13 control rooms plus recording area and so on. And we asked somebody to check the electromagnetic field, if we get any problems there in HF or low frequencies, so from power lines, for example, here with the low frequencies. And they checked and said, everything's fine, everything's okay, good, so we can go on. But later on, when everything was done, just keep in mind, 13 control rooms, a bunch of these control rooms were next to a street. And in these control rooms, we really had problems later on, because just under the pavement, there was a big power line, a main power line for the whole quarter. And every guitar pickup started making problems, and so on and so on. At the end of the story, we had to open up they had to open up the pavement and put the main line in the middle of the street, just to give you an idea what could happen. The problem was that the building site was so messy that they couldn't reach the region next to that street. And they checked all the rest of it just bit by bit, maybe 4 or 6 measurements, but they didn't go close to that point and thought everything's fine and missed this part where these control rooms were. Here's, for example, the main hall for the studio build, which Ingo mentioned, 301 in Sydney. This was the 4th building we checked regarding feasibility. This is 1,600 square meters plus an office building. This is all for studio. The good thing was here that the maximum possible load on that floor was very, very, very high. And we could build solidly on that floor. The negative thing was there's an airport close by, but due to the fact that we could build properly in here, that wasn't a problem at the end. This is, for example, the Wisseloord Studios. This was an existing studio. We had to renew nearly everything. So there was not such a lot to check, but we said, okay, we have to think about the control room. Are they really doing the job or not? You'll see that we had some issues in there. And there was something else. I don't know, I asked 3 or 4 times for it. Is everything really okay due to isolation and so on? And they said, yes, fine. And after a while, it came up, they do have a problem, but maybe this is just an easy thing. But actually it wasn't. They had transmission between these halls. If we go back here, so this is one hall, Studio 1. Studio 2 is another hall, and the 3rd hall, and separate building parts connected with this main street, this aisle here. This is the rest of the building, and there's an additional building here. Actually, I don't know if you can see my mouse, but I think you can imagine. And there was a transmission. Here you can see these 3 buildings in a section, Studio 1, Studio 2, and Studio 3. And first of all, I had to find out, where is it coming from? Is it really that easy to solve this problem, or is it a bigger issue? Here you can see, so these measurements we had to do to check what's the reason for it. So these are accelerometers, so acceleration sensors. Here I fixed it into the floor, into the ground, to the footing here, to the footing there, and here it's inside the room within a room construction of Studio 1, I guess it was, and check what the reason for this transmission is. Is it airborne sound problem, or is it something else? And we found out that the airborne sound isolation between these studios should be a lot better than it actually was. So this is the blue curve here. This is just a little part of a lot of data and measurements to give you a rough idea. And we, at the same time with these acceleration sensors, we checked the secondary airborne sound, so the airborne sound which comes from the vibrating surfaces, like for example the floor and the room with a room construction which stood on that floor. And the spectrum of these vibrations showed us pretty well that this was a problem of, it was a structural borne problem which we had to solve. And therefore, it was not just repairing a hole or a duct or something like that. So we had to check up the middle studio, the room within a room construction with altogether 38 tons. We had to check it up, put a new lower level footing in, and prepared a decoupling system. And then we put the room back onto that decoupled points. And then we had to dig out the whole ground, dig deeper, put a new primary slab in, and then a new floating floor with a tuning frequency of 15 Hertz. And then everything was quiet. So the next phase is define speaker setup. Is it stereo 5.1, immersive, placement concept like soffit mounted or freestanding speakers. Then define the geometry and size of the studio rooms, etc., etc. And also think about the isolation or insulation already, like we just saw, and define space for HVAC. It looks like this, for example. This was also Sydney. This was our first draft. This is part of the office building here, and this is the big studio number 1 with a hall, and all the other studios, and also the small studios in here. First of all, we wanted to build kind of a little cafe on top of here, but we ended up with this design here. Here, first ideas about the air conducts and how we work with this system here. Is there enough space? How high can we go? Is it all working, or is the ceiling height too low? And this is already, yeah, to be honest, the first draft. But you can see that this is about the needed sound insulation between the rooms and to the neighbors. And so there's all about the noise floors in each room, which is defined here, the maximum level in each room also, and then the needed isolation values between all these rooms here. So this is one of the main things to be done regarding the insulation of the rooms. And then you can decide how you get these isolation values. I'm very often asked about a very sensible issue. Yeah, what is the right geometry for a control room? Because we all know about the modal problems and so on. And I just want to talk a little bit about it due to time restrictions, I guess. So, for example, just think about a very simple situation. Typical room, 6.5 meters long, 5 meters wide. Everybody would say, okay, it would be nice to have a stereo image width of about 2.5 meters. The height of that room is 2.5 meters as well, like in most of the existing rooms. It's very, very, very common, these kind of dimensions and the expectations regarding the stereo image width. If we do so, the frequency response, the simulated frequency response up to 200 Hertz looks like that. a big dip here, which we call the 80 Hertz dip, which is typically for freestanding speakers. And we are losing all the low frequency end due to the fact that we are sitting right in the middle front to back. And we can't hear the lowest frequencies and the first tangential mode and so on. Bad, very, very bad. And I have to be honest, we cannot hear that later on. If we do a mistake here at that stage, you can't heal it by putting a Helmholtz resonator somewhere or even put a crystal on the speakers or something like that to heal that problem. That's really very, very important. I'm very often called to problem cases where I had to solve things and sort out things. And if this is wrong right from the start, it's very difficult to get this under control later on. So you have to think about it and you have to make sure this works. So here, for example, this is Mr. Rindel is a well-known engineer who did some drafts about best modal distribution, some papers. And this is one of his, I guess, his preferred ratio, 6.5 meters again, long. This is the width. And the height is 4.48 meters. And if you get to the best realistic position, it could look like that already, which is pretty good. But I have to say, if you once again try to do something like 2.5 or 2.6 meters stereo image width, then what you get is this. So even if you have a very good modal distribution due to these papers and these calculations, you could mess up big time. You have to be really careful with this. So in my opinion, you have to go one step further and think about, it's not only about modal distribution, it's also about the listening position and the speaker position. The problem is, these are the degrees of freedom: room length, room width, room height, position of the source, position of the listener. Okay, freestanding or soffit mounted speakers. Okay, we have to keep this out of the equation for the moment. But those are too many degrees of freedoms. So you have some issues with finding a good working room. And in addition to that, yeah, you have to stick to the realistic situation. So next step would be to reduce these degrees of freedom. So the question is, what do we know about that room? We do have nearly all the time limitations due to available space. So ceiling height, for example. There are some forbidden room shapes like a dice and so on, or very narrow and very long, which doesn't make sense, wouldn't make sense in reality. You can define a range of ceiling height, what makes sense. So for example, in this example up front was 4.5 meters room height. Where can you get that? Nearly nowhere. It's not realistic. Then the height of the listening position with your ear height, yeah, 1.25 meters. You're sitting behind your desk. This is fixed. The minimum distance to the front wall, because the speakers do have a certain depth. The stereo triangle is a limitation. You have to be left-right symmetrical, otherwise you would have different transfer functions between from the left and the right speakers. You always have to stick to the center line, and so on. Then there is an expected stereo image width. It doesn't make sense to have a room, let's say 10 meters long and 7 meters wide and so on, and you end up with a good position, a stereo image width of 1.2 meters. It doesn't make sense. So we have to keep this in mind also, this point here. Freestanding or soffit-mounted speakers, we had that already. Forbidden loudspeaker in source positions. I mean that it doesn't make sense to have your listening position just next to the wall at the back or just right in the middle, front to back. This makes life easier when you know that it doesn't make sense to look for a solution at these places. And the maximum source height. It doesn't make sense to have a low frequency driver at a height of 2.5 meters, for example. And then with these limitations, you can look for and kind of scan the range where it does make sense to look for a good position for speaker and so on. And you have less variables, and you can look then. We do have tools for certain situations to look for the best possible situation. This is, for example, a solution for such a room here. Okay, now we have to hurry up, I guess, already.
Yes, we have 3 minutes.
3 minutes left. Okay. So next thing, this is the end, more or less. I just want to go through and show you a few pictures. Next step would be to involve specialists into the project, like air conditioning and so on. Here, for example, we have had a structural engineer involved for a diffuser ceiling, because this is a wooden build, 100% wooden build. Here you see the problem with immersive audio. This is a reflected ceiling plan with all the speakers, and this is for Dolby Atmos, this is for immersive audio, this is for the main engineer and for audience, and the lights, and so on and so on. You see, and the screen, and you see how busy it can be, and those are our real problems. This is the 3D visualization of 3.1. This is the solution. We turned this is Wisseloord Studios. We turned the control rooms 90 degrees with a view to the sides. Those are mastering studios here. This is Sydney, the CMU built. You can see the maximum possible load on that floor here with the truck. Air conditioning. Heavy glass, carpenter's work, and the results. Sydney, Studio 1, view to the back, the main hall. Now I quickly run through these photos and then mastering, one of the mastering suites there. Smaller room. This is the Wisseloord. The hall in Studio 1. One of the mastering rooms. And thanks for listening. And I guess I'm in time, aren't I?